Hello, we are team number 4. Today we are going to talk about the shape of One World Trade Center. One World Trade Center has a beautiful and geometric shape. From now on, let's take a look at this geometry from top to bottom. As the tower rises from the square base, it tapers to the top, thereby transforming the square into 8 extremely tall isosceles triangles in elevation. For that point up and for that point down, alternating, culminating in a smaller scale at the top, half the size of the base scales. Halfway the shrinking floors at the 60th floor, the tower forms a perfect, eight-sided shape, the octagon. A geometrical three-dimensional object underlies the shape of one WTC and is called a square antiprism. The perspective drawing shows a uniform square antiprism consisting of two horizontal squares. The caps or base faces connected to each other by 8 equilateral triangles, four in upright position and another four in upside down direction. This shape is, for instance, relatively common in chemistry where 8 groups of atoms are arranged around the central atom, defining the 8 corners of a square antiprism. Another example is this triangular antiprism, disclosed only by triangles. It is also called an octahedron, a three-dimensional solid figure with 8 equilateral triangular side faces and 6 vertices. There are of course an infinite set antiprisms. On the left, a pentagonal antiprism with 5-sided base faces joined by a ring of 10 equilateral triangles, and a hexagonal antiprism with 6-sided base faces and 12 equilateral triangles. Antiprisms can be generated from prisms. For our square antiprism, this is the square prism, in other words, the cube. The parallel, concurrent base faces of prisms, like a cube, have the same rotational orientation. The square antiprism is a distorted cube with one of the bases twisted 45 degrees relative to the other base, like this. Antiprisms are similar to prisms except the spaces are twisted relative to each other, and the side faces are triangles rather than quadrilateral. On the left antiprisms with above their original prisms. The far left triangular antiprism is for instance generated from the triangular prism above by a twist of 60 degrees. On the left, a realistic object with the shape of a square antiprism. The two elongated boxes with a square footprint might be compared with the Twin Towers, although not depicted in correct proportion. Rotating the loop surface a quarter, an elongated or prolate square antiprism is created, with its outward sloping edge not an ideal shape of a skyscraper. The shape of one WTC is based on this oblong antiprism. However, contrary to a true antiprism, the top square has half the area of the bottom one. Evidently, the one WTC has considerably less volume than the original Twin Towers. The twisted orientation of the top square makes that, seen from the front, the tower has a box-like appearance with vertical instead of oblique edges. To elaborate a little more on this phenomenon, on the left a top view of the scale antiprism is shown. The dashed lines indicate the bottom scale, twisted relative to the yellow top scale. The top scale of the 1WTC is formed by connecting the centers of the side of bottom scales, indeed comprising half the area and indeed twisted relative to the bottom scales. The perspective drawing of the side view of the scale antiprism shows how the smaller top scales is generated from the bottom scales. On the left, a front view of the antiprism, and again generation of the top scales. The appearance of the resulting quasi-scale antiprism, in principle the shape of 1WTC, differ greatly. The front view show straight vertical outline and the side view tapering outline. Finally, two antiprism shapes were completed. These two antiprism shapes formed the superstructure of one World Trade Center, as you can see in this picture. One World Trade Center is compared to the former simple box-shaped Twin Tower. Now, follow some further comments on the shape of One World Trade Center, in particular regarding the shape of the building's base. The 185-foot steel and concrete base was added to the design in 2005 by architect Dave Child. It approximates a cube and had, in the original design, symmetrical outward sloping surface at the corner. This cutaway appearance is called a chamfer. This ground floor plan shows the chamfering of the corners. These corners slope gradually as they rise, at an angle of 3.8 degrees. It was said that this design was intended as a subtle homage to the cutaway corner of the original Twin Tower. The sloping corners are also included in this constructed image after the original design of the tower. That's where the substructure and the superstructure meet. There will be a strong load. To solve this problem, a strong steel node was used. There are 16 giant steel nodes on the 20th floor levels, and the ones at each corner is large as 60 tons and as high as 3 floors. These giant pieces act as joints between the steel framing for the building's podium and the steel for the remainder of the towers, and represent one of the signature elements of the building's unique design and appearance. The core and steel columns are connected via truss structure to increase the floor while maintaining the antiprism shape. The slope steel columns, which are started from the nose, form octagon shape with other straight perimeter columns. The outrigger truss connect core with the sloped columns to make structure stable and can create resistance against lateral force. Along the elevation of the building, the length of the outrigger truss changes fit cross-sectional shape of the building. With this structure, One World Trade Center combines the upper and lower structure. As a result, the lower and upper parts take on a somewhat distinct appearance. In the next presentation, we will study and present the floor plan and infrastructure in more detail. Thank you for our listening.